Question 38. Find the current through the 10 ohm resistor shown in this figure 32-E14. So in this question, this battery will try to send out a current, assuming that this is a positive terminal, so it will try to send out the current in this direction. This battery will try to send out a current in this direction, and its value will depend upon how the resistance values and these things are. What we'll try to do is we'll try to apply a Kirchoff voltage law, and one of the loops is this one. So one of our variables is going to be the current flowing in this 10 ohm resistance, and we will call it I1 because that is the one that we will try to find it out. And then we can take another variable I2 is the current flowing in this branch, and then I1 plus I2 becomes I1 plus I2 flowing in this direction. And when we solve, if the direction of the current comes out to be opposite, negative, we will know that the current is flowing in the direction opposite to our assumed direction. So I've redrawn this circuit here with I1 is the current flowing in this branch, and I2 is the current flowing from this 4.5 volt in this direction. So these two current I1 and I2 combine, and they become I1 plus I2 in this direction, 6 ohm. And when we solve this for I1 and I2, and if we get a negative value, we will know that the current is not flowing. For example, if I1 comes negative, it means the current is not flowing in this direction, but it's flowing in this direction. So first, one obvious loop for us is to find the current in this loop. And then how we solve is that we take all voltage sources on one side of an equation. This loop has only one battery, and that is 3 volts. And this battery will try to send out the current in this direction. So we will take this direction as the current flow direction, and in this current flow direction, the drop across this resistor is 10I1. So we write it 10I1. And then in this direction, we have, in this resistor, we see that the current direction is this. So the voltage drop across this 6 ohm resistor is IR, or I1 plus I2 into 6 ohm. So this is what the equation looks like. Now we need to solve for I1, so we keep I1 separate and I2 separate. We have 10I1 plus 6I1 is equal to 16I1 plus 6I2 is equal to 3. Now for the second loop, we can take this loop, and the problem with this loop is that we will have I2 and I1 plus I2. Another option is we can take this loop. It looks to me that this loop is simpler because we have only I2 current flowing here, I1 current here. We don't have to deal with I1 plus I2, and 2 batteries that we can deal with more easily. So these are the decisions you need to take quick to see which of the loops are simply more simplified version. So if we assume that this is the direction we want to traverse this loop, then on the right hand side we put all the batteries. So 4.5 volt is one of the batteries. I keep 4.5. And when we do this direction, then we see that this battery is trying to give out the current in the direction opposite to this. So we will subtract this 3 volt from this battery voltage. We have 4.5 minus 3 volt. And that voltage supply is equal to all the current drops in this direction. So voltage drop in this 3 ohm resistor is going to be 3 into I2, which I have written here. And then this direction is I1, and we are going against this current, so we have minus 10 I1 here in this equation. Minus 10 into I1. So we have 2 equations. The first equation of 16I1 plus 6I2 is equal to 3. The second equation is minus 10I1 plus 3I2 equal to 1.5. These are the 2 equations that we need to solve. We need to solve for I1 because we are required to find the current in the 10 ohm resistor. So we eliminate I2, and we multiply this equation by 2. 6 cancel. 3 minus 1.35 into 2 is 0. So this becomes 16 plus 20 is 32, I1 is equal to 0, or I1 equal to 0. So the current in this 10 ohm resistance is 0, and the way you can think of it is like this. If you remove this, for example, this whole thing, then this voltage gets divided in 3 ohm and 6 ohm in the ratio 1:2. So this becomes 1.5 volt here and 3 volt here in this direction. So the 3 volts due to this voltage battery here and 3 volt because of this battery here, they become equal for this 10 ohm, and then therefore there is no current in this. But that's for the way of thinking. You need to solve it using the Kirchoff voltage law.